Welcome back to another Recall by Data IQ video. Hi, my name is Chanin, Nantasenamat, and I'm a former bioinformatics professor and currently working as a developer advocate at a tech company in the SF Bay Area. Here, I have different types of M&Ms, original milk chocolate, almonds, crispy, and there's the peanut. And so in this video, we're going to be building a theoretical machine learning model for predicting the M&M types, which we'll be using as the class label. Before we begin, let's start from the basics by explaining the concept of sampling. So let's say that all of the M&Ms that have been produced by a factory in a given day, we're going to be referring that to as the population. And M&Ms that have been packed inside wrappers such as this will be called samples. Data. Data can be thought of as a quantitative or qualitative description of items of interest. If I were to take each of the individual M&Ms, and if I were to describe it in quantitative terms, I could describe the M&Ms by the dimension and also the weight of the M&Ms. And so these quantitative and qualitative descriptions of the M&Ms can also be called their features. And therefore, the different types of M&Ms will be known as their output labels or the class label, which we'll be predicting in this video. Dataset. A dataset can be thought of as a collection of labeled data, where each data sample is described by a set of feature vectors, also known as the X variables. And they are specifically tied to the class label or the Y variable. So back to the M&M example, let's say that each of these M&Ms represents a data sample. Then the collection of all of these M&Ms is the data set. And so I can document this into written or digitized form by creating a simple spreadsheet using programs such as Microsoft Excel or Google Sheets. Here, let me show you. Each row represents a single M&M. So if I have 100 M&Ms, I will have 100 rows. Now let's take a look at the columns. The columns are comprised of X and Y variables. The X variables represents the feature vector consisting of colors, size, shape, and the weight of the M&Ms. And the column also consists of the Y variable, which is also known as the output or class label. And they represent the different types of M&Ms consisting of peanut, almonds, crispy, and the original milk chocolate. Data preprocessing. In the real world, data is imperfect and can be quite messy. How? Well, there may be missing data, values may be misspelled, or values may be incorrectly entered. So what can we do about it? Well, the process of handling data so that we ensure that they are error-free is called data cleaning. And this involves replacing missing data with the columns mean, mode, and median, checking that entered data make sense and are correct. Data splitting. It is a process used in machine learning for estimating the model's generalization performance as well as for hyperparameter tuning. In simple terms, data splitting, as the name implies, involves splitting the data into smaller subsets. Data splitting can be implemented as follows. It could be done using the train test split, train validation test split, and also the EndFold cross-validation set. Let's now perform a data split using the M&Ms. So I pour all of the M&Ms into this cup. So all of the M&Ms are in here. And so let's say that this is our full data set. And it's from the contents of this milk chocolate M&M. And let's say I have two containers. Container 1 and container 2. And so I'll be dividing the M&Ms from this cup into each of these two containers. Right here. So the ratio is 80-20. So 80% will go to container 1 and 20% will go to container 2. So let me do this. 80% will go here, 20% will go here. So for every 5 M&Ms, 4 will go into container 1. and 1 will go into container 2. Okay, let's do this. So we have 4 and 1. And then we'll have another 4. Now we have 8. 8. And then 1 here. 1, 2, 3, 4. 1. 1, 2, 3, 4. 1. 1, 2, 3, 4. 1. 4. 1. 4. 1. 4 here. 1 goes here. And we have a remainder. And we'll just put it here in the training. So as you can see here, this is 80% and this is 20%. And so this is the train, test, split. So container 1 has 80% and container 2 has 20%. Alright, and so let's try out the train validation test split. So we have 3 subsets of data. So here I have 3 containers. Container 1, container 2, and container 3. And so the ratio will be 60% going to container 1, 20% to containers 2 and 3. So therefore, for every 5 M&Ms that I take out, 3 of those M&Ms will go to container 1, and then 1 will go to container 2 and 3. So let's do it. 3 to container 1, 1 to container 2, 1 to container 3. And I have a remainder. We'll put it into the first container. And therefore you have the 60, 20, 20 split. So we're going to use the container 1 as the training set, container 2 as the validation, container 3 as the test split. And so let's put it back. So I have here 4 plastic containers. So therefore, we're going to perform EndFold cross-validation. And so for this, we're going to be dividing it equally. So how many M&Ms I have in this cup, I'll be dividing it equally. Okay? And I have a remainder of 1. I'll put in the first one. So roughly now we have 4 containers. So we can see here now that the 4 containers have equal number of M&Ms. So in a practical situation where we're going to build machine learning models, in an EndFold cross-validation, you're going to take one fold and you're going to hold it out. You're going to keep it out, and then you're going to use the remaining 3 folds to build the machine learning models. Okay, so in iteration 1, you're going to use 3 of the folds to build a machine learning model, where you're going to leave out the first fold. And then once you build the model using the 3 folds here, containers 2, 3, 4, this model will be tested against the fold number 1. And so this is iteration 1. And so in iteration 2, I'm going to take the first fold, which I left out. I'm going to put it back, and I'm going to take out the fold number 2, which is the container 2. I'm going to take it out, and I'm going to use folds 1, 3, 4 to build a prediction model. And then I'm going to use the prediction model to predict on the left out fold, which is container 2. And then in the third iteration, I'll put back fold number 2. I'll take out fold number 3. And then I'm going to use folds 1, 2, 4 as the data to build prediction model. And then I'm going to use the prediction model to evaluate on the fold number 3, which is left out. And then in the last or 4th iteration, I'm going to put back fold number 3, and I'm going to take out fold number 4 and use it as the test set. Therefore, I'm going to use folds 1, 2, 3 to build a prediction model, and I'm going to evaluate that on the left out fold, which is fold number 4. And then I'm going to take the performance from the 4 prediction models, and then I'm going to have the average value. And that will be the average model performance from the 4-fold cross validation. Okay, so now I'm going to show the unwrapping of the remaining M&Ms. And I'm going to let you see how different are the different types of the M&Ms.
A few moments later.
Okay, so you have the peanuts, milk chocolate, crispy version, and you have the almonds. So you're gonna see that if you look at the colors, okay, it's gonna have similar colors. Let's have a look at the shape. This is spherical. This is somewhat globular, and the sides are not really uniform. And the weight could vary from each of the individual M&Ms. But these original milk chocolate, they're pretty much of similar size, as you can see. And the peanuts are bigger than crispy and milk chocolate, and the almonds are also quite big, and they're quite similar to the peanuts in terms of the size, and the weights are probably going to be greater than the crispy and the milk chocolate ones. So if I were to mix all of this together in one cup, and then for each individual M&Ms, we're going to be describing it by the size, the shape, the color, and then I'm going to use all of these X variables to predict the Y variable, which is the type of the M&M, whether it will be peanut, original milk chocolate, crispy, or almonds. Okay, so this is our data set of the M&Ms. Now that we have meticulously prepared the data set, we are now ready to proceed to the model building phase. So let's take a look at some of the types of learning tasks for machine learning. Depending on the data at hand, particularly on the Y variable, if the Y variable is quantitative, meaning that the values are numerical, then we're going to be building a regression model. However, if the Y variable is qualitative, meaning that the values are categorical, we're going to build a classification model. In supervised learning, the dataset is comprised of both X and Y variables. Such XY pairs constitutes the labeled data that are used for model building. As it is called the supervised learning, the XY labeled pair will supervise the learning algorithm to learn from past data. Particularly, regression and classification models can be built from this XY labeled pairs. In unsupervised learning, the dataset only has the X variables, may be used by the learning algorithm so that the inherent structure of the data can be modeled. Such machine learning task is known as clustering, which helps to identify data samples on the basis of their similarity. So those that are in similar cluster will represent that they are highly similar, whereas those that are from different clusters will represent that they are different. Model performance. After models are built, it is now time to evaluate how well they performed. And common metrics for evaluating includes the R-square for regression model and accuracy for classification models. There are actually more performance metrics, but perhaps a topic for a future video. Hyperparameter optimization. Did you know that you could enhance the model performance? In a nutshell, it's a process where hyperparameters or the model settings are tweaked, which correspondingly results in either an improvement or a degradation of the model performance. As there are no universal rule on which sets of hyperparameters works best in every situation, it must therefore be obtained by empirical testing through a process known as optimization, where several sets of hyperparameters are evaluated during the model building process, followed by evaluation of their performance. You can also check out the Learn Data IQ website, which has comprehensive coverage on various topics on how to build a machine learning model, as well as information on data preparation, feature handling, statistical analysis, data exploration, machine learning, and also various other use cases that can inspire you on your own data science learning journey. Speaking of learning, Data IQ's Machine Learning Basics is a 97-minute course that will get you started in building your own machine learning model in an intuitive and visual way using Data IQ's DSS platform. There's also a 60-minute course on Intro to Machine Learning, so I'll provide the links to these learning resources in the video description. So I hope that you found this video helpful, and I'll see you in the next one.